Okay, so we are looking at operations with square roots and even with the imaginary number square root of -1. So operations, remember those are addition, subtraction, multiplication, division, those type of components. So let's start off by looking at addition in our notes. So if we have a problem that says 3 times the square root of 2 plus 4 times the square root of 2, and a similar problem with our I of our imaginary number, a fancy way, just think about it as, what if this was x? What if it was 3x plus 4x? What would you do? You would combine like terms. So as long as you can say, okay, I've been doing combine like terms with x values for years now. It's not a new concept. The process is universal, whether it's an I, a radical, or my variable. Then it becomes a lot easier to be able to say, I know how to do this. The process doesn't change. As long as they are, aka, like terms, we can combine them. And that's okay. So obviously if this one was like a square root of 3, then that's not like terms, and we wouldn't be able to simplify it any further. So here are some examples with some other ways, though, that you might see these that make them a little bit more complicated, and I'm going to go really quickly, but I'll go back through the steps. So they try to trick them up. You might see something that looks like this. But the matter is, can I simplify? Is there a perfect square that I can pull out of 8? And in both of these situations, obviously, yes. And even here, it's like, okay, well, that's a -2. Anytime you see a negative, this comes back to watching our radicals, the imaginary numbers. But then you can pull out that -1, aka that I. So over here, you would say, okay, well, 8 is a factor of 4 and 2, and 4 is my perfect square that I'm going to be pulling out of it. This guy doesn't change. Doing the exact same process over here, but I include the -1. -1 times 2 times 4 gives me my -8. And this guy, I'm again going to separate out my -1. Since they're under 1, I can separate them into 2 separate radicals and roots. Over here, I just do it by 3. 3 here and 2 here. I can take the root of each one separately now, which becomes 2. So now I have 3 times 2, because 2 is the square root of 4, times the square root of 2. And over here, I take the root. This guy doesn't change. And the root of -1 is technically I, is what we use to to denote that. Okay. So 3 times 2, easy enough, 6. Square root 2, 4, square root 2. And over here, now I just have 6I. I move this I to the front, square root 2, and 4I, square root 2. But now I've created like terms. So just because at first they don't appear like it, doesn't mean you can't simplify them, and so you do actually have true like terms. And then you can combine them. What about subtraction? Subtraction works the same way as with variables. 7x minus 3x would give me 4x. So if roots, as long as they're like roots and like terms basically, then it's going to work the same way even with the imaginary number I. If you're subtracting, you see something like this. The distribution is going to be the same. This is the same thing as distributing by -1. So 1 times 2, 1 times the square root of -1 times the square root of 2. Same thing over here. Okay. And you can't simplify any further. Now what about multiplication? Multiplication throws in a little extra piece with our I, and we'll get to that in just a moment, and can even with our square root 2 sometimes. So again, we'll just use the distributive property and distribute. And so that's one thing you might see. No big deal. I can't simplify any further, and I'm done. What if I have something that looks like this, and I actually have a coefficient in front of my radical or my I? Then just like if that was 4 plus 5x, then again you'll multiply your coefficient. So if you see something like that, that's an example of how you'd go about it. Now, but what if you have something that looks like this? This gets a little bit more complicated. Obviously, we're going to multiply and multiply, but when we get to here, our coefficients are going to multiply, but so are our radicals and our roots. And the same thing over here. My coefficients are going to multiply, but then also I times I is going to happen as well. And so if you're multiplying something by itself, that's the same process as squaring it. If you're multiplying something to itself, that's the same process as squaring it. And as we know, when you square a square root, which this is nothing more than, I is nothing more than the square root of -1. So if you square the square root of -1, you're going to bust out that -1. It's going to simplify down to -1. So this guy stays the same. Here, this simplifies down to 3. Here, it simplifies down to -1. So you have to remember this little extra bit that it doesn't just become I squared, but you're actually squaring the square root of -1, which then simplifies to -1. On our left, we're just going to rearrange. And if you chose to rearrange on here, 8i and you're done. So the process of working with the roots and working with the i's are going to be very similar. And they're even very similar to working with our normal exponents. So division. And the same basic rules are going to exist in division. Anything divided by itself, no matter what it is still 1. Regardless if it's a root or even an imaginary number. So you can still reduce and simplify out the square root of -1 if something has you dividing by it. But here is a catch. This is a very common mistake with our radicals, is that people go, oh, well, this has a root in it, and it has a 3 in it, so I want to eliminate those. You cannot do that. If you go to your calculator and type in the cube root of 3, you are going to get a number that is not 3. Because this is not 3. This is whatever number you ever have to multiply to itself to get 3. And that divided by 3 does not equal 1 because it's not going to be the same. So this will forever stay this. Okay? If there was a 3 on the outside, then you can break them up and reduce anything on the outside. But anything inside the radical sign is protected from division down here, obviously, unless it is identical in another one of these situations. Okay, so I follows a very similar category. I divided by itself is 1. If you have whatever on the same thing on top is the same thing on the bottom, still 1. Even if you have something that looks like this, though, you can simplify out that I, but this 3 here is still protected in a totally different number because it's the square root of 3, and thus you cannot divide by 3. So those are some basics of operations with roots, including the imaginary root of -1. So I hope this helps.